In this video, we're going to be talking about different ways in which we can measure the variability of our data set. And by variability, we're going to mean that how much does our data change throughout the entire data set. So the easiest one that we can address is the range. And the range is a pretty simple concept. We say that the range of our data set is equal to the largest value that we have, which we're going to call x max, minus the smallest value that we have, which we're going to call x min. So to get the range, we just put in our values here. So if we're going to use our data set above for our example, we're going to say that our range is equal to x max, which in our case is 18, the largest value in our data set. So we're going to say 18. And then we're going to subtract off x min, which for our data set is the 6. So we're going to say 18 minus 6 is equal to 12. So 12 is the range of our data set. Now the other method that we have for measuring variability is with what is called the variance of the data set. And for the variance, we're going to have two slightly different formulas, one for the population variance and one for the sample variance. So we're going to talk about the sample variance one first because it's the one that we're going to be using most often throughout this class. So the sample variance we're going to denote with an S squared, and that's going to be our sample variance. And the formula for that is equal to, very similar for calculating the mean with some slight changes. So it's just going to be the sum from I is equal to 1 up to n. So far we're having the same as our mean. But now we have our xi's, our xi value minus our mean, which is, since we're dealing with samples, we have x bar, and that whole value squared. And then we're going to divide that by n minus 1. So if we look at this formula, we're walking through for I is equal to 1. So we're walking through each of our individual values again. So when I is 1, we have x sub I is x sub 1, and which is equal to 7. When I is 2, we have x sub 2, and we have x sub 2 is equal to 13, and so on. And our x bar is that same sample mean that we calculated before. So we would add all of these values up and divide by the total number of values we have. So in our case, 7. So 7, or that value, which we calculated to be 12, is going to be subtracted off from each of our individual data points, and then we're going to square those values and add up all of the squared values and divide that total sum by this n minus 1. Now the only change here from our sample variance to our population variance is one is the symbol. We have our symbol for our population variance is this sigma squared, and we're going to say that the population variance is equal to, in this case, it's the sum for I is equal to 1 up to n. And now it's going to be our x sub I. And now, instead of minus x bar, since we're dealing with a population, we're going to subtract off our mu, so our population mean. And we're going to square that value. And we're going to divide that by our n, which is our total number of data points in our population. And there's a slight change here where we're having n minus 1 for our sample and n for our population. That's kind of outside the scope of this course to talk about why we're doing that, but it essentially comes down to we're using our n minus 1 value over here to get the best possible estimate for our sigma squared. So our s squared is our best possible estimate for sigma squared when we're dealing with a sample. Now let's just walk through a simple calculation of our sample variance. And the way that I like to do that is just kind of like in a tiered step approach. So the way that we're going to do this is we're going to start off with our data points. We have our data points up here, and we're going to label those as our x sub i's. And now, since we know that our x bar, we knew x bar is equal to 12, we're going to walk through and subtract off 12 from each of our different data points and use that as we keep going. So for each row, we're going to do in the next step of our equation. So we're going to have our next line is xi minus our x bar. So for 7, it would be 7 minus 12, so we're going to get a negative 5. For 13, it's 13 minus 12, so we get a 1. 16 minus 12 is 4. 11 minus 12 is negative 1. 13 minus 12 is 1. 18 minus 12 is 6. And 6 minus 12 is negative 6. So now that we have that next step, we're just going to square all those values. So we're going to get our xi minus x bar squared. So we're just going to walk through and square each of these. So negative 5 squared is equal to 25. 1 squared is 1. 4 squared is 16. Negative 1 squared is 1. 1 squared is 1. And 6 squared is 36, which is the same for negative 6 squared. So the next step that we have is we're just going to add all these different values up. So if we add all of these values up for each of these, we're going to get a total of 116. So we get 116, which is equal to our formula for the top of our function here, which is the sum from I is equal to 1 up to n of xi minus x bar, and that value squared. So now the last step to get our sample variance is just to divide this value by n minus 1. So we're going to have 116 divided by, since we have 7 minus 1, we have 7 minus 1 here. So we get 116 over 6. And if we actually divide that out, we get 19.3 repeating for our sample variance. So the last thing that we're going to talk about in this video is what is called the standard deviation. So the standard deviation is simply the square root of the variance. So we have our 19.3 here, which is our sample variance, which we know from before is equal to our s squared. And we're going to get our sample standard deviation. And the sample standard deviation is going to be called s, which is just equal to the square root of the sample variance, so s squared, which is equal to the square root of 19.3, repeating, which is equal to 4.3969. And that's just going to be our sample standard deviation. We have the same formula for the sample or the population standard deviation. So the population standard deviation would be sigma, which is equal to the square root of sigma squared, which is again our population variance. So population standard deviation is the square root of the population variance. Sample standard deviation is the square root of the sample variance.